This is lesson 1.3 in trigonometry, and we're going to get started in actual trigonometry today, and we're going to start talking about trigonometric functions. So, trigonometric functions, let's see if I can spell that. Trigonometric. Trigonometric functions. All right, there are six trigonometric functions, and we're going to stick to mainly three of them, but once in a while we'll get to the last three. And they all have to do with this xy axis here. So we have our graph. You know, there's our x line, there's our y line. All right, so I need you to really follow what we're doing here, because if you get this, trig will be fairly simple for you. If you don't get this, it's going to be a struggle. And it's not that this concept is hard, it's just that it's kind of new. So, let's look at this. The distance between here and here is on the x-axis. So this distance is x. So to go from here to here, we go a certain distance from the origin. Now in this case, we're going in a negative direction, but the number here could very easily be a number like 6, because the distance is always a positive number. It's just the direction you're going that can be negative. So let's say that that length there is 6 long. And let's even put the direction on there. Okay. Then if we go up to this point here, so we went over this far and we went up this far. So we went up a distance of y, right? Okay, so let's get rid of our numbers here. Let's stick with just the letters for right now. All right, so in order to get this point that we have right here, we went over x and up y. This distance from here to here is going to be r, because that's the radius. If we were to draw a circle, and if this is x here, and this was x here, and this distance is y, and maybe the distance to the bottom, the distance to the bottom of that circle from the origin is also y, we have a radius right here of our circle. And this is, we're going to call it a unit circle, and we'll get into more on unit circles later. But what trig functions are basically ratios. One ratio compared to another ratio. So let's say, for instance, that we want to know the ratio of y over r. That's all we want to do, is we want to find that ratio. So if this were 6 and this were 12, the ratio would be 6 over 12. 6 over 12 is the same as 1/2, right? So that ratio, y over r, has a name for it. So when we're just looking for that decimal, that fraction, in this case it was 1/2, we call that ratio the sign. It's spelled S-I-N-E. It's written S-I-N. It's abbreviated. Big deal. We abbreviate sign by taking off an E. But all of the trig functions have 3 letters, so they just took the E off. And the name of the angle that we're taking the sign of is this one right here. And when we don't know that angle, we call it theta. If you remember, in the last chapter or last section, we were calling the unknown angle theta. So the sine of theta is y over r. Or you could say, from the angle theta, let's put a little theta there, it would be the opposite over the hypotenuse. Y over r is the same as the opposite line across from the angle over the hypotenuse of the triangle. So O over H. Let's say, and I'm going to go ahead and put that theta back on there. Let's say that we are interested in finding out, we're going to scribble this theta out, we're not going to use that one. We want to know the ratio, let's see, x over r. We did y over r, so let's do x over r. Or that could also be called, to theta right here, the adjacent side, the one that lies next to it, over the hypotenuse. Well, we call that ratio the cosine. But rather than write the INE, we're just going to write COS. Please don't call that cos. Please don't call this sin. People will laugh at you. So the cosine of theta is x over r, or a over h. The ratio of the adjacent side over the hypotenuse is called the cosine. All right, so we did y over the ratio, and we did x over the ratio. Now let's do this side over this side. And we're going to do y over x, or the opposite over the adjacent. So if we're looking at that ratio, we call it the tangent. But again, we're down to 3 letters, so we're going to get rid of everything except the tan. And we're going to put theta there. So the ratio of y over x, or opposite over adjacent, we're going to call the tangent. All right, so that gives us 3 of them. And let's go ahead, and I'm going to get rid of this picture here, if I can, so that I can put the next ones on here. All right, so we had sine of theta is, I said y over r, or the opposite over hypotenuse. The cosine of theta was x over r, or adjacent over hypotenuse. The tangent of theta was the ratio y over x, or opposite over adjacent. Way to remember this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That gives you an old Indian name of Sohcahtoa, Chief Sohcahtoa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And then you can very easily figure out what those are based on what you've got here. Okay, so I said there's 3 more. We have what is called cosecant. Cosecant, and if we're going to write that with 3 letters, we're going to write it as CSC of theta. And what the cosecant is the sign turned upside down. So instead of y over r, we're looking at the ratio of r over y. The next one is just called secant. And we're going to call that 3 letters. Secant of theta is cosine flipped upside down. So instead of x over r, it's r over x. The third one then is cotangent, and 3 letters, COT of theta. So the cotangent of theta will be the tangent flipped upside down. So instead of y over x, it's going to be x over y. Okay, so that is real simply the 6 formulas you're going to need to know. I would memorize them. You're going to memorize them just by doing the work. and that will help you as we continue on with these lessons. So this is the end of 1.3a.